Energy efficiency retrofits, such as installing ducts or replacing propellers, have been carried out on hundreds of ships over the past decades. The main motivation has been and still is to reduce fuel costs, particularly for vessels operating off design conditions. Looking ahead, the case for retrofits could become even stronger. New builds can be costly and involve long lead times, depending on ship type, size, and shipyard capacity. This can make upgrading mid-life vessels a more attractive alternative compared to ordering new tonnage. At the same time, the introduction of greenhouse gas regulations, such as the EU ETS, FuelEU Maritime, and the potential future implementation of IMO net zero framework can serve to increase both fuel and compliance costs. As a result, retrofits that were previously considered to have too long payback time could now increasingly become more financially viable, paving the way for a broader range of energy efficiency solutions than before. This backdrop raises important questions for owners, operators, and technology providers. Which solutions are the most promising? What makes a retrofit successful? And how can the industry scale upgrades effectively? To help explore these topics, I'm joined today by Nuno, head of the Marine Solution Business Division at Hanwha Power Systems, a company that provides a wide range of retrofit solutions for ships. Welcome, Nuno, and thank you for being here. I will jump straight into the first question, which is, in your opinion, what are the most important factors influencing the technical and the financial feasibility of an energy efficiency retrofit project?
Hey, thank you, Øyvind. I'm pleased to join this important session. To your question, I think we may divide the retrofit projects by two. Firstly, there could be a kind of mandatory retrofits driven by international regulations, such as BWTS or scrubber systems. For these, the decision-making process for the ship owners, I think, is relatively straightforward, and it's definitely cost-driven, with owners typically leading the execution. Secondly, there are retrofits for performance enhancement, I think, such as adding or modifying energy-saving devices like air lubrication systems, wind-assisted propulsion systems, or any kind of hydrodynamic devices. This is the case you asked. For this, I think verification of effectiveness is paramount. While the theoretical benefits are quite clear, the burden to prove real-world gains is on technology providers. I think third-party verification could be also one meaningful approach, helping both parties. I mean, both means the suppliers and owner side. From the perspective of a full EPC provider like us, I think it is equally important to provide intelligent and automated operating systems that can ensure these devices perform optimally under any fluctuating environmental conditions. If it shows practical improvement, everybody can take it. So in summary, the most important factors that influence feasibility of projects are cost and the performance improvement.
Hmm. What would you say are the typical challenges encountered during a retrofit project, and how can they be overcome?
Yes, the challenges vary depending on whether we are talking the negotiation stage or at the execution stage. Until the firm contract made, the primary hurdle is how we can provide the owner with excellence in the ROI. Crucially, the owners need to know if they can recover their capex through adjusted charter rates from charterers. This is already mentioned in the previous subject. And as a solution provider, our job is to reassure the client by demonstrating superior technical expertise and robust project management capabilities. During the execution stage, one of the most frustrating cases I've experienced is discrepancy between the provided as-built drawings and the actual status of the vessel. We've seen cases where some stiffening structures were applied differently than indicated on the provided drawings. If the case is external, visible side, it could be prevented by 3D scanning before detail engineering started. But if that happened to internal structures, I think there is no way but to rectify during the construction stage, means additional cost. I don't know if class of site has some ideas of preventing this kind of issues by any means during the new building stage.
You mentioned costs, and of course, off-hire time can lead
Mhm.
to increased costs for the owner. What is the typical timeline of a retrofit project, and what steps can be taken to minimize off-hire time?
Questions. There are many kinds of retrofit projects. I can say some typical cases. For a major project like an LNGC to FSRU conversion, the total timeline is spread about 24 to 27 months, which is from detailed design to delivery. However, the actual installation or construction period, which is more important to the owner, is about 6 to 7 months, I think. To minimize off-hire time, we front-load the design and procurement phases so that construction work begins from that moment the vessel enters the yard. Constant communication regarding the delivery window is vital to ensure minimum lost time. For smaller projects such as liquefaction enhancement for LNG carriers, it takes about 1.5 months. Increasing container carrying capacity by expanding lashing bridges on large container carriers, it takes just slightly over a month. Since these projects usually executed during the scheduled dry docking, simple application of equipment such as PWTS, etc., can be within the scheduled docking period. Anyway, I think we must coordinate firmly with the shipyard and ensure the design is flawless to avoid any rework.
Mm. Taking a step back, which retrofit solutions and technologies do you think have the highest potential across the fleet today?
Yeah, including my own interest in the business, I can say in the short to medium term, we see steady demand for FSU or FSRU conversions of aging LNG carriers. Dual fuel engine retrofits for conventional vessels are also high interest items. Through though decision making has been slowed down recently as the owners digest the last MEPC meeting outcomes. We are also closely watching the liquefaction system upgrades for old LNG fleet. And looking further ahead, once regulations become more defined, I anticipate a surge in OCCS installations. For the short sea shipping segment, I'm monitoring the demand for electrification and energy storage system application quite closely.
I think that's all we had time for now. Thanks again to you, Nuno, for sharing your experience and perspectives with us here today. And I will now hand back to the studio.